Alright, so before we start the actual going over specific questions, here's a little bit of background about quadrilaterals. So there are 7 quadrilaterals that you need to know about. Let me zoom in a little bit. Okay, let's start with parallelogram. Okay, alright, so this is a parallelogram. Alright, the definition of a parallelogram is that the opposite sides are parallel. That's what these little arrows mean. Alright, we'll talk more about the properties of a parallelogram in a minute. For right now, I just want to go over the definitions. Okay, now, as we go down this chart, alright, so we started with parallelogram because everything below is a parallelogram. A rectangle is a special kind of parallelogram. Okay, that's why it's below parallelogram in the chart. Okay, because notice a rectangle, the opposite sides are parallel. That does make it a parallelogram. What makes a rectangle special is that, yeah, it's a parallelogram, but it also has these 90-degree angles. Okay? So if you see 4 right angles, then you know it's going to be a rectangle. Now, on the other hand, another special parallelogram is this. It's called a rhombus. Hopefully you can tell by the markings. The thing that makes this special is that all 4 sides are equal. Alright, so if you see all 4 sides equal, that's a rhombus. Okay, now don't forget both of these are parallelograms. All of these are parallelograms. Now, if you put those two concepts together, you have a square. Now, a square is a rhombus and a rectangle at the same time. A rhombus has 4 equal sides. A rectangle has 4 right angles. Okay, so it'll be a square if you have 4 right angles and 4 equal sides all at the same time. So that's a square. Okay. Now, there are 3 more shapes that you need to know about. This is called a trapezoid. And hopefully you can tell from these markings right here. These markings mean parallel side. Not equal. It means they're parallel. That just means they're going the same way. They're not equal in length. Okay. Do you know what parallel means?
They're going straight.
Yeah, they're going in the same direction. Like these 2 lines, for example, that I just drew, those are parallel. These 2 lines are parallel. They never cross. Even if they kept going forever, they would never cross. Okay, so a trapezoid has 1 pair of parallel sides. So notice that this and this are parallel. The yellow sides are parallel. But however, this is garbage. But for example, these sides are not parallel. Only the yellow sides are parallel. Okay, so that's what makes a trapezoid, 1 pair of parallel sides. Now, this is also a trapezoid. That's why it's underneath here. But it's a special kind of trapezoid. It's called an isosceles. Isosceles trapezoid. Okay, an isosceles trapezoid is a trapezoid, so it has 1 pair of parallel sides, but the legs, these are called legs, by the way, leg. The legs are congruent for an isosceles trapezoid. Okay, so there's one last shape, and this is called a kite. All right, a kite has two pairs of congruent sides, and they are the ones that are touching. You know, we say they are consecutive. So this side and this side are equal in length, they're congruent, and this side and this side are congruent. All right, so if you have two pairs of congruent sides that are consecutive, they're touching, then you have a kite. All right, so those are the 7 shapes that you need to know.
Okay.
All right, now each one of those shapes have special properties, and eventually you need to memorize them. But I'm just going to briefly mention them now, and then we'll refer back to them as we go over some specific questions. Parallelograms. This is the most important list because half of the shapes I just showed you were parallelograms. Rectangles, rhombuses, squares, all of those are parallelograms. So here are the special properties. In addition to the definition, which is that opposite sides are parallel, we also know that opposite sides are congruent. Okay, so for example, if this is 7 over here, then this will be 7. If this is 5, then this will be 5.
What about the rhombus? Because you said the rhombus is all the same. So how is that?
Yeah, we'll get to the rhombus. We'll get to rhombus next. All right, but this is just for, in general, all parallelograms, opposite sides are congruent. Okay. Also, for parallelograms, opposite angles are congruent. Okay, so for example, if this is a 60-degree angle, then this is a 60-degree angle. Okay, if this is a 120-degree angle, then this is a 120-degree angle. So opposite angles are congruent. That's another parallelogram property. All right, here's another property of parallelograms. Diagonals bisect each other. All right, diagonals bisect each other. Bisect means cut in half. Okay, so when I say diagonals bisect each other, what I mean is, for example, if this is 5, then this is 5. They cut each other in half. If this is 6, then this is 6. In other words, this point is the midpoint of the blue segment, and it's the midpoint of the red segment. Okay, so diagonals bisect each other. They cut each other in half. And one more property. The last property is that consecutive angles are supplementary. Do you know what supplementary means?
180.
That's right. They add up to 180 degrees. So for example, when I say consecutive angles, I mean angles that are on the same side, like these two. So for example, if this was 100, can you tell me what this angle would be?
80.
It would have to be 80, because they have to add up to 180. Okay, and it'd be the same thing over here. Okay, so those are the properties of all parallelograms. Now let's talk about the special properties of a rhombus. Okay, for a rhombus has 2 special properties. Let's see. For a rhombus, the diagonals are perpendicular. That's the first property. So here's what that means. The diagonals are perpendicular. So this is a diagonal and this is a diagonal. But for a rhombus, those are going to be perpendicular. So they're always going to make a 90-degree angle.
Oh, okay.
Okay, so that's something, eventually you need to memorize this. But for right now, this is good notes. Alright, now there's one more property for a rhombus. Okay, the diagonals are angle bisectors. Why did I put symmetry in? Okay. The diagonals are angle bisectors. So That means if this was, say, 30 degrees, then this would be 30 degrees, for example. If this was 60 degrees, then this would be 60 degrees. So the diagonals are angle bisectors. Okay? So those are two properties for rhombus. Again, the diagonals are perpendicular and they are angle bisectors. Now for rectangle. The definition of a rectangle is that you have four right angles. Okay, so we've got that. In addition to that, for a rectangle, the diagonals are congruent. All right, so for a rectangle, all right, this is a diagonal and this is a diagonal. Now for a rectangle, those will be congruent. So for example, if the blue line is 20, the whole thing, then that means the red line is also 20. Okay, now that's only true for a rectangle. For example, for a rhombus, that wouldn't be true. For a rhombus, one of these could be 20 and one of them could be 15. The diagonals don't have to be the same for a rhombus. Okay, now don't forget about a square. I put it off to the side here because, wait, this is hard to control. Don't forget, a square is a rectangle and a rhombus. So a square is going to have all three properties. A square is going to have diagonals that are perpendicular. A square is going to have diagonals that are angle bisectors. And a square is going to have diagonals that are congruent. All right, a square has all of those properties. Okay. Now let's talk about a kite. In a kite, diagonals are perpendicular. So if I have a kite, this is a diagonal and this is a diagonal. In a kite, those are going to be perpendicular. All right, I know this is a lot to remember, but that's why it's good to just have this as a sheet of notes to refer back to. And one more thing about a kite is the one diagonal is going to be a line of symmetry. All right, it's going to be an angle bisector. And I'm talking about this one. Okay, so for example, if this was 60 degrees, then this would be 60 degrees. If this is 30 degrees, then this is 30 degrees. All right, this long diagonal is an angle bisector. All right, last thing. So remember, a trapezoid has one pair of parallel sides. But what we know is that leg angles are supplementary. So when I talk about leg angles, I'm talking about these. All right, these are supplementary. So remember, so it's like if this is 80, then this is 100. Okay? Or over here, if this is 80, then this is 100. All right, leg angles. Okay? And then for our special case, isosceles trapezoid. All right, that's the one where it's a trapezoid, but the legs are congruent. In addition to the thing about the leg angles being supplementary, these are called base angles. All right, those base angles will be congruent. Because it's isosceles, it's going to be the same on the left and the right. That was supposed to be an eraser. Hold on. Hop, I erased the 53. So for example, if this is 53, then this will be 53 over here as well. Okay? And it's the same down here. How would I figure out what, see where I'm putting a question mark right now? How could I figure out what that question mark is?
Diagonals are congruent.
That's true, but the leg angles here together,
Is that the same as 180?
yeah, these have to add up to 180. Okay, so how could I find the missing one?
180 take away 53?
Exactly. 180 take away 53. Okay.
Yeah, 120.
That's 100 and what?
27.
127. Okay. All right. So that would tell us this is 127. And then because it's isosceles, okay, because it's isosceles, this would also be 127. Okay? Because for isosceles ones, these have to match.
Okay.
Okay, so that's a lot of background information that I just covered. Okay, now let's look at some specific questions and see how we do. Okay, so this is question number 1. All right, for a craft project, 2 equilateral triangles are taped together to create a quadrilateral. So we have these 2 equilateral triangles as shown. Now, do you remember, what do you call the shape that has all 4 sides congruent?
A rhombus.
That's a rhombus, okay? That's why the answer to this was a rhombus. By the way, I need to mention something to you. Okay, we went over a lot of different things and names. But when they ask you to name something, you have to be as specific as possible. So remember, we have all 4 of these things are parallelograms. Rectangle, rhombus, square, parallelogram. They're all parallelograms. But if I give you a rhombus, you can't just say parallelogram. You have to be as specific as you can. You have to say rhombus.
Wait, repeat that one more time?
Okay? Here's what I'm saying to you. Let's see. Let me go to the black screen. No, that's not the black screen. All right, you have to be specific, okay? So, if I give you a shape, like for example, this. All right. This is a type of parallelogram, okay? But if I ask you to name this, you can't just say, oh, this is a parallelogram.
Why not?
Because this is a special parallelogram, and it has a more special name than just parallelogram. What kind of parallelogram is it?
Rectangle?
It is a rectangle. So even though it is a parallelogram,
You have to be more specific.
you have to be more specific. So you have to say rectangle, not parallelogram. All right, here's another example. Okay, I'm going to give you a shape and you have to tell me a name for it.
A square?
Right, okay. It's also a rectangle. It's also a parallelogram. But you can't say rectangle. You can't say, it's even a rhombus.
Yeah.
All right, this is a rhombus because all 4 sides are equal. But you can't just say rhombus or parallelogram or rectangle. You have to say square because that's the most specific name that you can give it. So that's what I'm saying here. This is a parallelogram, but luckily that's not even one of the choices. But even if parallelogram was a choice, you would have to say rhombus because it's more specific. All right, let's look at the next one. Okay, this is actually problem number 3 because I'm going to do all the odds. All right, so this is problem number 3. They want to know what's the value of x. Well, this is a rectangle, I can tell because of the 4 right angles, and which means it's a parallelogram, and the opposite sides should be congruent. So for example, that means this and this should be congruent. That means I should be able to make an equation like 10 plus 2x should equal 18. Alright, so I should be able to subtract 10 from both sides. All right, 2x is equal to 8. Divide by 2, x is equal to 4. All right, makes sense?
Yeah.
All right, this is number 5. I'm continuing to do all the odds. So they tell us that this is a kite. And so they're showing me that these pairs of sides are the same. Now for a kite, this line down the middle is a line of symmetry. So if this is 14, I mean it's the same on both sides.
Okay.
So like if this is 14 on the left, then this is 14 on the right. If this is 22 on the right, then this is 22 on the left.
Okay.
So what is the length of segment BC? Well, that's 14. All right, it's the same as AB.
Okay.
Okay. Okay, so they're telling us that this is a kite. This time it's laying on its side, but still we know that, so that makes this the line of symmetry. So that means that angle M and angle K should be the same thing. So if angle M is 118, then this is 118. All right, a kite is the same on both sides.
What about those numbers in the middle?
They don't matter to this particular question. Like, they don't have to be the same, obviously, since one of them is 78 and the other one's 46. But the question just simply asks us for the measure of angle K. And so all we needed to know that angle K was 118.
Okay.
Okay? All right, here's problem number 9. I got a dotted line right there. So this is a parallelogram, and one thing that we know about a parallelogram is that consecutive angles such as these are supplementary. Okay, and you know that that means that these two angles have to add up to 180. I hear you saying. All right, so that means 11x plus 6x minus 7, that has to equal 180 degrees. Now 11x plus, right, that's 17x. Okay, then I would add 7 to both sides. Okay, and now I'm going to divide both sides by 17. All right, do you have a calculator for me? Okay, that's 11. So we know that x is equal to 11. And let's go ahead and use that to find the angles. So if x is equal to 11, and this angle right here is 11x, so that's 11 times 11. So that is 121. All right, that means the angle across from it is also 121. All right, because those should be the same. Yeah, this is a parallelogram. Okay, they said it here that it's a parallelogram. Also, they marked the opposite sides have those little arrows showing that they're parallel, so we know it's a parallelogram. Okay, right now I could subtract from 180 to find the other angle. Or I could plug in 11. Either way. So I could do 6 times 11 minus 7. So that's 66 minus 7. So that's 59. I also could have subtracted 121 from 180.
Okay.
Either way, I now know that these angles are 59. All right, now let's see which of these statements are true. X equals 11. Yep, we found that. Angle L is 22. Nope, is 59. Angle M is 111. Nope, it's 121. Angle N is 59. Yep, we found that. Angle O is 121. Yep, we found that.
Okay.
Okay. Alright, so this is number 11. We are told that this is a kite. However, we are not even going to need the special properties of a kite in order to solve this problem. We just need to know that all of the angles of any quadrilateral add up to 360 degrees. So if I start from 360 degrees, I notice that I have two 90-degree angles given to me. If I subtract those, so minus 90 minus 90, so far that leaves 180 degrees. That means that the two angles that are left have to add up to 180 degrees. Okay, so let's figure that out. So that means that 18x minus 2 plus 12x plus 2 has to equal 180 degrees. Do you understand what I've done so far?
Yeah.
Okay, so solving this is like normal. So this will be 30x. Oh look, the minus 2 and the positive 2, they just cancel each other out. So 30x is equal to 180. And then I'm going to divide by 30 on both sides. So that's 6. So x is equal to 6. Now I'm supposed to be finding angle VXY, which is this angle down here. So for that reason, I'm going to take my 6 and I'm going to plug it in right here. Okay, so if I plug in 6 for x right here, then that's going to give me 12 times 6 plus 2. Okay, so that's 72 plus 2, that's 74. Alright, that's why the measure of that angle is 74 degrees.
I have a question.
Oh look, we got another kite. Another kite. They want to know the length of CD. But look, remember for a kite, if you look and see the sides that are the same, so the 3x plus 1 and the 22, those are the same. And these are the same. So if this is 4x, then this is 4x. Alright, but first of all, I'm going to use this, the fact that the 3x plus 1 and the 22, those have to be the same. So that means 3x plus 1 has to equal 22. Does that make sense?
Yeah.
So if I subtract 1, that gives me 3x is equal to 21. So x is equal to 7. Okay, now we're supposed to find segment CD. Alright, segment CD is this pink segment right here. I know that that is 4x. So if I take this...
So 7 times 4?
Exactly. Alright, if I take this 7 and plug it in, that makes this 4 times 7. Don't crash. You can do it. That makes this 4 times 7. That's 28. That's why the answer is 28.
Yeah, 28.
Alright, this will be the last problem of the lesson. This is number 15. We're told it is a trapezoid. Okay. Now, because it is a trapezoid, one of the properties that we discussed was that consecutive angles, or I think we actually called them leg angles, because this is a leg and this is a leg. Leg angles are supplementary. Okay, so I can pick any one of these and make an equation out of it. I know they are supplementary.
So 9x equals 180?
Okay, so 9x plus 90 equals 180. Alright, they have to add up to 180 degrees. So 9x plus 90 equals 180. Does that make sense? Alright, so then I could subtract 90 from both sides. So that's going to give me 9x is equal to 90. Then if I divide both sides by 9, that'll give me x is equal to 10. Are you with me so far? Now we're supposed to find the measure of angle F. Okay, angle F is right here. Okay, and I see that it is 14x. Okay, so that means 14 times 10. If I take this 10 and plug it in. Alright, and of course 14 times 10, like you just said, is 140. Alright, that's why the measure of angle F is 140.